You know, when it comes to data, it's often the problems you can't see that are the most dangerous. Today, we're diving into these silent data errors, the kinds of glitches that don't set off any alarms, but can cause absolute chaos behind the scenes.
So let's just jump right in with a question that really hits home. What if this happened to you? Imagine you're in charge of a university. On the surface, everything looks perfectly fine. But deep down, one of your most critical systems has gone completely off the rails, and there's not a single warning light flashing. What do you think happens next?
All right, let's get into it. Section 1, the silent data glitch. We're going to unravel just how these sneaky, hidden problems pop up in the first place.
Just picture this for a second. The student information system. It just malfunctions. No red flags, no system alerts, nothing. It just quietly starts overwriting weeks and weeks of course records. The very first sign that something is terribly wrong is when the phone starts ringing off the hook. Panic students wondering where their grades are. And just like that, in an instant, all the trust in the institution is hanging by a thread.
So you're probably asking, how does something like this even happen? Well, that brings us right to our second section, when quality isn't enough. This is where we really get into the limits of our traditional data checks. And this right here is the absolute heart of the problem. A system can be screaming, everything's fine, all checks passed, all the rules are followed, but at the exact same time, some silent little mapping error is just wiping out thousands of crucial GPA records. So the data looks clean, right? But it's completely fundamentally broken. This really highlights the danger, doesn't it? The very system that's supposed to catch errors has no clue that a critical piece of information, something students desperately need to graduate, has just vanished. A really great way to think about data quality is to imagine a pilot's pre-flight checklist. It's an absolutely essential process, no doubt about it. You're checking for all the known issues. Is the format correct? Is the data in the right range? You're basically making sure all the boxes are ticked before your data pipeline takes off. And right there, that is the million-dollar question. A checklist is only as good as the things you already know you should be checking for. But what about the curveballs, the unexpected problems? That's where we need something more. And that brings us to the solution. Section 3, enter data observability. If data quality is the pre-flight check, think of this as the in-flight monitoring system for all your data. So what is it really? Well, data observability is all about continuous, active monitoring. It's not just about checking against some static list of rules. No, it's about watching the behavior of your data, how fresh it is, how much of it there is, and whether anything just looks off. Let's go back to our airplane analogy. If data quality is that pre-flight checklist, then data observability is the entire instrument panel in the cockpit. It's monitoring everything in real time. It's looking for unexpected turbulence, like a sudden nosedive in data volume or a schema that changes without warning, and it alerts you the second it happens. So how does this whole thing actually work? Well, it's pretty cool. First up, it's constantly monitoring freshness. Basically, is your data showing up on time? Because a delay could be the first sign something's busted. Then it tracks volume. It's watching for any weird drops or spikes, like, all those student records suddenly having 0 GPAs. It's also on the lookout for anomalies and schema changes. These are the unexpected twists to the data structure that your normal quality checks were never designed to find. And finally, it traces lineage. This is amazing. It lets you follow the data's entire journey so you can pinpoint the root cause of a problem in minutes, not days. Okay, I know this might sound a little abstract. So for Section 4, we're going to talk about real-world data disasters. Let's look at what happens when these silent errors actually strike and see just how high the stakes can get. Our first case study takes us back to the height of the pandemic in 2020. Public Health England was using a system to track COVID-19 cases, and this was data that was absolutely critical for the entire country's response. And then this happened. Nearly 16,000 positive COVID cases just went unreported. And why? Because the system was using an old Excel file format that had a row limit. The system simply stopped recording new cases once it hit the ceiling. No warning, no error message, nothing. This is exactly why the traditional checks failed. Think about it. You can't run a quality check on data that was never even recorded in the first place. An observability system, on the other hand, would have instantly flagged that the volume of new cases had just unnaturally flatlined and would have triggered a major alert. And if that wasn't dramatic enough for you, let's turn to the world of high-stakes finance. Back in 2012, a major trading firm, Knight Capital, experienced what can only be described as a catastrophic failure.
In just 45 minutes, a software glitch cost the company $440 million. It nearly bankrupted them. The scale of this failure is it's mind-boggling. So what was the cause? A single server that failed to get a software update. That's it. It was running old, obsolete code that suddenly started firing off millions of faulty trades. A data quality check would never see this. But an observability platform, it would have detected that insane anomalous spike in trade volume in seconds and shut it all down.
And all of this brings us to our final section. Now, the crucial takeaway here isn't that one approach is bad and the other is good. It's all about creating a powerful partnership between quality and observability. When you boil it down, the difference is this. Data quality is focused on enforcing the rules you already know for the data itself. Data observability, on the other hand, is focused on detecting unexpected behavior to monitor the health of the entire data system. One is about validation, the other is about real-time monitoring. They're really two sides of the same coin. You absolutely need both. Data quality sets the standards, and data observability acts as your 24/7 guardian, watching for anything that deviates from the norm. It's when you put them together that you create a truly resilient and trustworthy data environment. I think this quote just captures the shift in mindset perfectly. It's about moving away from reactive firefighting, cleaning up a huge mess after it's already happened, to proactive assurance. It's about catching those silent errors in minutes, not months down the line. So that really leaves us with one final, pretty heavy thought. Data failures, they don't exactly send you an invitation. They just creep in silently. The real question isn't if the next silent error is going to happen, it's when. And when it does, are you going to have what you need to actually see it coming, or will you be caught completely by surprise?
For further questions, feel free to reach contact@datagaps.com. Scan the below QR code for free demo. Thank you.